I'm the author inventor of Pakistander, which you'll see on full display for these demos. It's available everywhere. I think as of last month, it has passed 1 million downloads, and it's currently tracking on about 400 downloads a day. It's being taught in universities. I know at least one in France has a part of their coursework. In New York, if you were to take a class, you'll have a 3-part lab series on Pakistander. And I get lots of hits from senior design students. You'll see plenty of that in this presentation. I'm also the author of this book, which you should not buy because it is at least 8 years out of date. It's about web game development, and I can't not think of any technology that moves faster than gaming and web. And I wrote a book. So if you want to see how that state of development was 8 years ago, you can pick this up. There is one part that is still relevant. Let me find it. It's about 15 pages where I talk about installers, how to build an installer on Windows and Mac. That actually has not changed much in the past 10 years. So that is still relevant. I believe on Apple, you have to notarize your app now. So that's the only difference. So if you want to flip through it, I brought a copy so you don't have to buy one. I'm also the author of 2 network patents. Does Sweden care about US patents? I don't know. Perhaps they do, but anyway, we can talk about that. But I want to get into the demo. So, are we all familiar with Wireshark? Yes, most people. Absolutely amazing packet sniffing tool. If you ever get into network development, troubleshooting, you'll become very familiar with this tool, and you'll absolutely love that it's available. In tandem with Wireshark is my app, Packet Sender, for packet sending and receiving. The idea behind it is you launch Packet Sender right here on one window, Wireshark on the other. Between the two of them, you can troubleshoot, reverse engineer just about any network protocol, and you'll see plenty of that. I'm going to do just a quick run through before moving on, because it's a whole lot easier to understand if you just see it. So here it is. It launches immediately. That's thanks to C++, not Electron desktop apps that was talked about the other day. So it launches very fast. Up at the top, you get your IP addresses, your current IP addresses. Sometimes you just want to know your IP address. And I don't know why, but operating systems like to bury that somewhere. But here you look at the top. If you want to know more, the subnets, that's all right here. And then you set up your packet name, the ASCII, any kind of ASCII notation. It supports slash codes, /r/n/t. If you've done software development, you'll know what that means. Control, line feed, tab, and it gets translated to hex right here. So between the two of these, you can define just about any kind of packet system that you care about. So any kind of format. This line is actually very, very forgiving. So I know a lot of places they use colons to separate the hex. So you can put colons right there. You can put X's, you can put spaces. I know some tools use H's to designate hex, and it'll just fix it. You can even have just no delimiter at all, and it'll fix it. So you should be able to copy and paste from just about anything and put it in. And when all else fails, load your file directly and toss it in, and you're good to go. Once you have your data, you set your IP address. I have one set up right here, your port, resend. This supports down to tenths of a millisecond, and TCP, UDP, and HTTP protocols, which I will not get into today, but familiar with the tool Postman. So this has kind of its own little mini Postman system going on. And down at the bottom, it can listen to any number of ports that you want. So UDP, TCP, SSL, those are ports it's listening to. IPv4, IPv6. We'll just do a quick test. So send. If you're familiar with the DNS lookup system, then this packet might make sense to you. Turn on persistent TCP so you can hold a connection. And I just did an FTP connection into Debian, sent it, and that's the response from the FTP Debian server. Here's another good one. We'll move down to an SSL connection, so SMTP for Gmail. There it is. So it did an encrypted connection, handled the negotiation, and it sent back the response. So you can do encrypted testing if you want with those sockets. Um, this collapses if you want. When it does an SSL connection, it gives you information about the SSL itself. So it made the negotiation and it encrypted with found the cert GTS, that's Google cert. I'm not authenticated with anybody because it's a self-signed. And AES 256 was the encryption scheme. So another useful thing about this, when you're developing sockets and encrypted sockets, your SSL may not be ready yet, or there's probably bugs that you're trying to figure out. So we'll do a quick test of that with cert mismatch. There we go, right here. So I made a connection, and it did not match the host with this certificate. So there's a certificate error, and it tells you what it is. But what it does, it just connects anyway, so you can transfer your data and then figure out later why it's not working for you. As with every nice tool, there's Easter eggs. So I'll show you right here. If you want to admire my two puppies, hold control PUP. That shipped for free with every version of Pakistander, just for you. And of course, there is the command line interface. Just about everything you can do over here, you can do over here. One in particular that might be of interest to you is this right here. This is the intense UDP traffic generator tool. So you can just flood your network, and you get a few knobs about how you want to flood it. I actually got an email about this the other day. Somebody was telling me, it's like, I think someone's DDoSing me with this tool, this traffic generator, and he sent a screenshot of it. And my answer was, well, that's neat. Why would they use that when they could have used the command line, which is faster? And you get more knobs to tweak it. All right, so that's a quick run through of Pakistander. Screenshots are good. What I have in bold are the things I'm going to cover today. So we just got a brief overview of Pakistander. We're going to control devices beyond their original apps. The idea being, I have an app running on here, and just say it's Windows only, but you're a Linux user. You want to reverse engineer it. There's all kinds of valid reasons you want to reverse engineer it. So we're going to reverse engineer it. For automation, you saw the command line utility. Just about anything you can do in the command line, you can script. And then the malware analysis. So let's get this going. Before I have to go further, does everybody know what the difference between UDP and TCP? I see half the nods. The way you remember is TCP, point-to-point, guaranteed delivery, error correction. UDP, send and forget. Now, there's all kinds of reasons why you would want to use UDP versus TCP. You'll get to see both in action. So, but just keep that in mind as we go through this. All right, PyPlayer. I have PyPlayer running on my Raspberry Pi right here. It is open source. I wrote it specifically to be reverse engineered during live demonstrations. I didn't want to hack. I mean, we can call it hack. I don't want to reverse engineer or hack someone else's tool, live on stage. So I made my own tool just to hack it on stage. And it's right there on PyPlayer. It has the web server. Actually, it's not a web server. It's a control server, TCP raw server, built straight sockets. It has a desktop app, and there is a web app if you're interested in using it to make some kind of music player of your own. It's not a very good music player, but it's great for live demos. The Raspberry Pi 400, it's actually fairly new. Has everybody seen one of these? It's very new. I think it may be like 6 months old, but this is a self-contained Raspberry Pi 4. So it used to be you would get a box and you'd assemble it. You would have to glue the fan on it. But if you're lazy like me and you're just like, well, here's an extra $20, just do it all for me. you can order these guys, and it's so convenient. I just want to make clear that this. It didn't look like one, but it actually is a Raspberry Pi. All right, let's do this. Here's my setup, Pi, switch, display. We're good. Okay. This is the Pi Player app. What I Can you see that there's 4 buttons up there? It's hard to see. There's actually 4 buttons. I didn't realize it was so dark. But at the top, it's going to find the Raspberry Pi. So I just found it, and the other buttons become enabled. Play, next, and stop. So I hit play, the command came in, and now my display is playing music. Now play the next song with the next button. Hit next. Here we go. There it goes. And stop, obviously. So I want to reverse engineer this app. So I need to figure out what those 4 buttons do. I need to figure out how it finds the Raspberry Pi. I need to find out how the play button works. I need to find out how the next button works and the stop button. So that is my goal for this demonstration. And if you remember our discussion that I basically skipped, since you're all experts, about the difference between UDP and TCP, I want you to think about what each button could be. So to get started, we launch good old Wireshark. So I know at least, I think it was about 50% nodded yes, but for those who are shy and didn't say yes, it's okay. You're learning. Wireshark picks up packets that are listening onto the wire. And what I want to do is look here and see that I have actually, let me disconnect from Wi-Fi. There we go. Whenever I do network troubleshooting, I highly advise you go into your settings and just disable the network adapters you do not care about. It'll save you a lot of hassle then on. I've seen so many weirdness, especially with VMware. If y'all use VMware, what it'll do, VMware loves to pick up a random IP address that conflicts with other things in your network. Also, Docker is really bad about doing that. Docker is extremely common. So I think it defaults to 172.12 or something, which is extremely common for local networks. So just go in there, disable all of them except the one that you want. It'll save you a lot of troubleshooting later. So I'm going to listen on, let me restart since I confused it. There we go. There is my Ethernet. And I'm going to listen for UDP or TCP traffic on Ethernet. There we go. Traffic is happening. Restart. I'm going to find the Raspberry Pi. Is it going to be UDP or TCP? Which do you think it is? UDP, we'll see. And you are correct. We have UDP. It can't be TCP because TCP is guaranteed delivery and has no idea where it is. So that's one way to think about it. And let's look at the address. So it's sent to 255, 255, 255. What's special about that address? It's a broadcast, that's right. So the way it works, hit the button, it sent a packet to the switch and it relayed it to everybody, and the Raspberry Pi replied back, and that's how it found it. Now what did it do after that? We can look at the response, and there it is. Server address, its own address. So that's how it found the Raspberry Pi. That's what I need to replicate. So let's launch Pakistander. Two five five, 255. What port? Port 15,000. 15,000. And it did fine. That was the response. What did it send? It sent find units. Alright, this should work. Then send port cannot be blank. Too many zeros. There it is. So I reverse engineered that button. Now I need to reverse engineer the other buttons. So hit play. There it is. Next. Stop. Now, I want to side note. You notice when I hit play, there's like a pause going on. Or sometimes at the end I hit stop, there's a pause going on. There's two reasons for that have nothing to do with the network. First of all, it is a Raspberry Pi and it's reading off of a very slow SD card. Also, there are serious inefficiencies in my Pi player code that I did not bother to fix. Now, we have been doing lots of asking if there are any questions. I'm just going to seed some questions throughout that you can ask me. You can ask me, why is your code slow? So that's something you can ask about for Pi player. Because I would love to deep dive into optimizations for code. All right, so we played, we next, and we stopped. Let's see what those commands are. I forgot to ask, is it TCP or UDP? It's TCP. Let's find it. So TCP, we found one. There it is. Play. That's the command. And it's sent to port 15,000. So I'm going to save this. 0, find, pi. So let's save this guy. I stuck a 0, so it'll sort up at the front. Now we'll do play here. That's my play command, and it sent a unicast to my Raspberry Pi 0.169, and it is TCP. Save that. And let's find the next one. There it is. Next. The next command is next. How incredibly original I am. Save that guy. And now, let's see what stop is. There it is. Stop is stop. Excellent. Stop. I typoed. Just to be different, I'm going to use the DNS here right here, just to show you that you can do that. I have a DNS entry called Raspberry Pi Audio. You can follow my mouse down to the bottom of the screen. I'm going to tab over, and that's the resolve that DNS entry. So I can save that. Pakistander also supports IPv6. If you want to get that going, you can click this, and it'll go into IPv6 mode. And I have an IPv6 DNS entry for that. And there it is down there. I'm not going to use that because my PyPire code does not support IPv6. But it's in there if you want. While I'm here, one other neat thing that you can do is that might be really helpful in your testing is macros. So Pakistander support, first of all, before I get ahead of myself, let me save this. Oh, I did save it. So if you want to send a unique string, you can do bracket macros. And I want to send the time, and then I'm going to just send that to, I don't want to confuse my Raspberry Pi, so I'll just send it to myself. Do send UDP. See, there we go. So like I sent a big unique string, and then I sent the current time. So there's about 5 or 6 macros in there, and the idea behind that is you want to test something. So you might have a series of tests where you might just want to send this like every half second, and then it just goes on and on and on. And you can see in the logs of whatever device you're testing against when it fails. So you know the string, you know the timestamp. You can look at the first one and the last one and compare the two, and that's when your device failed, and you can go figure out what's going on. All right, so let's stop this and actually hit the play button. There it is. So play, and that was the response. I actually don't need persistent TCP. Next, and stop. Oh, there it is. All right, so I did it. Reverse engineered. So I can take these and I can, export them, go to some other device that uses, like on a Mac or Linux that maybe this app does not run on. Before I go further, have you ever been taken a class? The one that comes to mind to me that is famous for this is like math class, such as calculus, where the professor goes up there and teaches you how to find the derivative. They'll go up on the board and just do this massive algebraic equation and spend 40 minutes to find the derivative. And then at the end of the class, they'll say, oh, by the way, there's an easier way to do this. It's the power rule. Exponent times coefficient minus 1 or something like that. There's an easier way to do what I just did. But you need to know the hard way before I show you the easy way. So I'm going to do this again, and it's going to be a whole lot easier. So I actually don't need all of this. So I'm going to clear these out, and we're going to reverse engineer this again, and the easy way. So capturing in Wireshark is all well and good, so you can get and copy and paste over. But what's easier than capturing in Wireshark is just having the app tell me its command. So we're going to do it that way. All I really needed to know is the port that it's running on and the protocol. So we know that it's running on port 15,000. So I'm going to set Pakistander to listen on port 15,000. For both of these. So Pakistander can listen on any number of ports that you want. So I'm interested in 15,000, but if you want to listen to more, you can just, put it right here, just comma separate it, and 9,000. And the same with the SSL server. So there we go. No, I do not have it to ranges. That would be useful. I completely agree. But you can just, that's way too many numbers. So you can just keep right on going, as far as many times you can type, but it does not do ranges. That would be nice. I agree. Go to the GitHub, click on feature request, and file it. And then maybe a couple months from now, it might do ranges. All right, so I want to send a reply. So I got it set up right here, ready to go. So my address is 0.99, and I already have it ready to go. And I'm going to hit OK. There we go. See, I'm listening to all kinds of stuff. See, this is listening to 5 stuff right now. And anyway, hopefully 15,000 got buried in there somewhere. And restart Pi player. And I need to disconnect my Raspberry Pi. See, I got it all nice and color-coded. For you AV enthusiasts, I worked in the AV industry for like 7 or 8 years. So red means audio, yellow means video. There we go. I tricked it. I told it my address was 0.99. Now he's talking to 0.99. That's where he thinks the Raspberry Pi is. So let's clear out this log right here and just do, I don't need persistent, and then I hit play, next, stop. It just told me his commands. That's a whole lot easier. And now I just need to save these off. So save, play, save, next, save, stop. I'm not quite done yet because it's talking to me instead of the Raspberry Pi. But we know where the Raspberry Pi is already. So 169. Oops. I need to copy that. There we go. There we go. Now I need the port. Just copy and paste, copy and paste. There we go. We shouldn't need this guy anymore. Reconnect. This takes about 5 or 6 seconds to register. I think it's good now. So let's find the Raspberry Pi. Nope, I don't want to flood. Turn off, respond. So when you send a broadcast with replies, auto reply enabled, it warns you about flooding because you could be sending like to 1,000 things. It comes back and it'll be sending back out again. So a flood warning. So find the Raspberry Pi. My Raspberry Pi is not connected. What do I have wrong here? All right. Could not connect. I'm going to remove these ports. My switch turned off. Why is my switch off? Okay. I think my power source is having issues. So what I'm going to do is I'm just going to reboot my switch. These power sources are not super reliable. It can handle about 4 amps. I'm surprised the switch is consuming 4 amps, but I don't know. So this hopefully won't take too long to reboot. While we're at it, I'll show you other tools that you can use with this. So, does anybody use multicast for anything? I see no hands. Multicast is extremely useful. So you're all familiar with broadcast packets, right? That's when you flood the network. Well, not flood the network, but you send it and it just gets routed to absolutely everybody. If you don't want to do that, so notice that PyPlayer used multicast to find it. The modern way to do that is actually with multicast, where you join a stream and then the Raspberry Pi or whatever device you're trying to do will heartbeat back. And then that will get captured. That way, you're not just sending packets all over the place willy-nilly. That's the modern way. That's actually how your computer finds your printers using the Bonjour protocol. So my switch is back to life. And there we go. Now I'll hit play. All right, now I want to do one more thing. So you see how this has a nice GUI? I would like a nice GUI. So Pakistander has built-in paneling tool. So I'm going to generate a panel, and there we go. Yeah. Now I don't want to just beat this drum, but what you could do is you can go in here and just start scripting, additional things. So I could make another button that we'll just call it yay, and I want to send play. Then I want to delay 5 seconds, and then I'm going to send it stop, and so in about 5 seconds, you just send the stop command. There we go. So, so you can build this like this very complex control panel system, and there's like lots of very expensive tools that do this, but now you can just launch it this way. So anyway, that's all well and good, but I know you want to get to the malware demo. How am I doing? I'm doing pretty good on time. Let's keep at it. So there's malware on this Raspberry Pi. I don't think I have to explain what malware is. I have a slide just in case. But I do this presentation for university students, and what I want to stress to them is that malware is basically anything that's bad on your computer. So you know how it is. You get a complaint, and someone says there's a virus on my computer, and then the pedantic sysadmin comes in and is like, oh, that's not a virus, that's a worm. And the guy's like, I don't care, just get rid of it. I mean, so I want to teach my students, and I want to teach the general user to just say malware, and then they're correct, because just about everything is a subset of malware. There's malware on my computer. It's like, oh, okay, you just save that conversation. Because they really don't care what it is. They just want it gone. And to be fair to them, I don't blame them. It's like they're not paid to know those differences. They're paid to just not click on things, bad things. So that's the only thing I want to talk about. So you can do that to your users. Just delete all mentions of virus, worm, Trojan, blah, blah, and just replace with malware, and we can simplify the language. So here's the setup. I don't need this display, which is good because I just saved myself an amp and a half. And all I need is my Raspberry Pi. The switch is still on, so let's do this. Oh yes, this is fake malware. I did not write malware and upload it to GitHub, so don't report me or anything. The source code is inside PyPlayer. You can look at it and laugh about how dumb it is, but this is just purely simulation. All right, let's look at it. Let's get this going. To start with, I'm just going to do a free run capture of my Ethernet, and I have all my other adapters disabled except Ethernet. So this, and it's an isolated network. And let's see what happens. There we go. I already got something interesting. My Raspberry Pi is ARPing for 192.168.0.1. The ARP protocol is how it finds the location of other devices, so it can get the communications going. Why does it want to know 0.1? That's normally my gateway. It can't find it because it's an isolated network. Why would it want my gateway? Yes, talk to the internet. Why does it want to talk to the internet? Well, usually that's okay, but in my case, I can promise you this is not okay. So what do? I'm going to give him that address. So I'm going to network, and I know you can do this in PowerShell, but I'm intentionally showing you this method because one, I'm a Linux guy. I don't know the magic PowerShell. It's like netsh. And plus, I want you to know this method in case you want to do it yourselves and you're not a PowerShell expert. So one thing I've noticed is not common knowledge, is that your your Ethernet cables. Actually, every network adapter can have multiple IP addresses. I don't know why that's just not common. Like they get the idea, like one device, one IP address, but you can add as many IP addresses as you want. I think the technical term is alias address. So I'm gonna add myself another address. I don't know why Windows bears this under like 5 advanced menus, but there we go. Okay, and you can see here it's up at the top. It got listed right there, so it's active now. Let's run it again. So it should be able to find that IP address and continue on to the next step. There we go, I got something. It's probably a little dark and hard to see, but he found the gateway. And I was telling the gateway, it's like, I want to connect to this random IP address out on the internet. It's actually not random, that's my web server. I'm not going to point to some other guy's service. But he's trying to talk out to the internet to that IP address, and he can't get there because it's an isolated network. So to fix this, I'm going to, once again, give myself an IP address. This address, to be specific. So back to Ethernet. Advanced. And I can't remember. There it is. Add. This one is 138. 197. Dot. 192.94. No, that's 84. Let me double check it. 138, 197, 192, 84. There we go. Add. There we go. And there, it appeared right here. All right, it's active. Restart. So now he should be able to find that address. We continue on chasing this malware, see what it's trying to do. All right, he found it. He tried to connect, and it broke because there's nothing there. So when the way this would manifest in your browser, or if you try to connect something, it would say like connection refused, because he found the IP address, but the connection was refused. I know you've seen that error page in your browser at times. That's how that manifests. So what is he trying to connect to? He is trying to connect to 5123. So how do I continue on? Well, I'm going to have Pakistander listen to 5123 and see what's happening. So TCP server 5123. And we should be good to go. I'm going to turn on persistent TCP connections. Now we wait for the capture. Boom! There it is. I caught it. Turn on. What is this? Copy to clipboard. Let's blow it up a little bigger here for you. So imagine half of you recognize what this is already. So this is an Nmap scan. What did it find out? Well, it ran on May 29th, so it was several days ago when I was, checking this demo is okay. And then it was found I had SSH open. I'm running on an Apple computer and all kinds of interesting stuff. So what's going on is on my home network, this IoT device, it ran an Nmap scan. It captured it, and then it tried to send the report back up to the mothership to await further instructions. What those instructions are, I don't really know. So what the next step would be is for me to take this and then send it up there myself, capture the response, and just continue chasing down this trail, which I won't bother to do. Just so you know, my website, my servers actually does not have that port open, so you would get connection fused. This is all simulations. I got to keep saying that. So now, are there any questions about what I've shown? This actually went a lot faster than I anticipated, so instead of breaking, I'm just going to dive directly into part 3, but I can pause right here for questions. Like, yes, yes. So the question was, can I set up Pakistander to respond to messages, I guess, in a more intelligent way? And that the answer is yes. It's not super intelligent, but there is some there. So the first one, which I showed you earlier, let me close this out. Actually, see this running just nonstop. Um, you saw this already. Send a basic response with macro support. So if you wanted to, you could do, bracket Unix time, and it'll do a macro response. If you want to, you can do smart responses. So enable smart responses, and if the packet equals this, then reply with that. So you can say the notation of it, and then you can enable each one. So you get 5 slots, and you can use macros. If it equals this, reply that. It's not super smart. It would be neat to make it smarter, have some kind of wildcard filter or something like that. But it's a start. So maybe that will do what you need to do. It could be enough. So it supports TCP, UDP, SSL, and just a quick note about SSL. I have to make sure everybody knows this. SSL is the general term for encrypted socket. All versions of SSL are obsolete. They're broken. You should move to TLS. So when I say SSL, I'm actually mean SSL or TLS. It just so happened that all the documentation reference materials still say SSL, and nobody wants to rewrite that stuff. So underneath is actually SSL TLS, and the support for the SSL TLS is whatever your OS supports. Now for Windows, I actually ship OpenSSL with the tool because I can't rely on whatever Windows is doing. And you can see what OpenSSL version it's using if you go to About, and it's written right there. So this is shipped with OpenSSL 1.1 built on April 20th. On Mac, it's whatever library is built in, and on Linux, it's whatever libraries are built in. So whatever on Windows, whatever that version of SSL supports, Pakistander can do. Does that answer your question? Okay. All right, so I can continue on, or we can break for about 15 minutes. All right, let's do it. Next demo. This is a bonus conference. So I'd like to thank them for giving me a little bit extra time so I can show you this bonus demo. So this talk is about teaching latency versus throughput, which I'm sure most of you already know, but you can also give this a subtitle, How to Make the Sysadmin Angry. So So this is going to teach you network latency, network throughput, while also making your sysadmin very mad. And you'll get to see that in a moment. So I don't think I need to define these terms. I think most of you know it, but here it is anyway. Latency is delay between packet sent to packet received. It's usually measured in milliseconds. Just a note, it can be measured either way. Sometimes it's measured with going from here to there. Sometimes it's measured going from here to there and back again. So the complete return trip. I've seen it either way. So if you're particular about it, you'll need to ask to define the terms. Throughput is how many bytes can be sent in a certain amount of time, usually bytes per second or bits per second. So you have the unit is second, or on the other one, it's per second. It's a very subtle difference that can confuse students a lot. And I always tell them, when you talk about your network and your network performance, and you want both, because they could tell you, this is a gigabit. It's like, well, that's great. What's the latency? Or you can see, my ping is less than a millisecond. Well, that's great, but what's the throughput? Because you need both in order to be able to say that your network is decent. And quick note before I move on, PowerPoint suggested a ping pong icon right there, and I just kept it, because why not? All right, I liked it. All right, so let's live demo latency through, but I like very few slides and lots of demos. So if you were to add up all the slides that I've been using, it might come out to like 15. So let's get this going. For this, I'll be using a KMax device right here. You can look it up. I won't go into details about it. But basically what it does, you put it in between on your network, and there it is. So you put it in between your network, and it degrades the network in ways that you can control in order to test devices. I do a lot of software development, and I'm very concerned about network performance, about my tools. It's very common that when you have, say, like an app, the app runs like garbage. Why does the app run like garbage? Because the developer is over here sitting at his desk with like an i7 computer with 32 gigs of RAM, and the database is either one hop over, or even better, running at localhost. So of course everything works perfect. Now I don't fault that setup, because after all, the hardware is cheap and developer time is very expensive. So you want that. You want them to have all those tools. But once you ship it and you give it to people, say like me, who live in Alabama and have to go visit relatives out in the boonies, I have one bar, and now the app behaves like trash. This device right here, as well as other network degradation devices, can help you test this. So keep that in mind during your development. So let's get to the demo. Now the goal is to test latency and throughput through the process of network degradation. So I'm going to connect to my Raspberry Pi. So I have a VNC connection into it. This saves me a monitor from stealing juice right here, and it also lets you get to see it nice and easy. So let's get this going. I'm going to launch a couple of terminal windows. This is just running stock Raspbian OS. Actually, I think they renamed it to Raspberry Pi OS, but it's just running stock. And what I'm going to do is I'm going to launch a Python web server. A little technique: if you ever want to transfer a file from one computer to another on your LAN, that is actually surprisingly difficult to do. I know there's things like nearby share that Windows does from Windows to Windows, but if you want to do cross-platform from, say, Linux to Windows or Linux to Mac, that's actually really difficult to set up. But most things now have Python installed, so you can just launch a quick Python server in the directory that you want. Let me check. There it is. Python. There it is. And now you have a nice, easy, simple file transfer, download. So let me launch the other one. There we go. So that's 1, and that's 2. So it's an easy way to just transfer files. Just launch a quick Python web server. Now I'm going to take this, and we'll see the throughput. I'm going to curl. There we go. It's run a bit slow at first because it's caching, but you can see here it's downloading about 40 megs. The next time around, I'll probably say 90 because it's pulling it off the SD card, which is kind of slow. But anyway, I have really good throughput. Now the other thing I want to check is latency. So let me ping a Raspberry video, and I have less than a millisecond. So that's excellent. I have really good latency, well, very low latency, and I have really good throughput. So is that better? All right, yeah. So I have really good throughput, really good latency. Now the next thing I want to do is trash the network so we can get a good test. So to do that, I'm going to go to the KMax device. Now, I'm not going to just load in the scenario. Like before, I'm showing you the steps in case you want to do something like this on your own. You can see here I have data transferring right here and right here. So I'm going to go to the default band. And let's kick off the download again. There. See, it's cached, so now it's topping out. And we can see the spike right here. So the traffic's happening this way. So we're going to add a classifier, a filter, IP port, and I am pulling that from port 8001. So source port 8001, and this one does support ranges if you want to do something like that. TCP. So pulling from 8001, TCP, apply, close. And I'm going to send this to flow 1. Start again, double check. There it is. So I pulled off that slice and sent it to this flow. So now I can do all kinds of interesting stuff to it. If you're curious where all these other spikes are coming from, it is my VNC connection itself. It's representing that. So we are going to rate limit. Enable 100K. There we go. Close. Now this should behave very badly. There we go. It's like 16 days, 10 days, 8 days. I think it eventually settles down to around 3 days, 5 days when I did this before. So that is horrible. That is basically unusable beyond anything except maybe browsing text or telnet services or whatever. But here's the really wonky part of this test. I'm going to do curl. I'm going to do this number 2, and then I'll make it bigger again. Let's try. My null command got screwed up. Curl. There it goes. close this out and just open up a new one. So you make it, expand it, then I can make it bigger. There it goes. So this is going to finish in about 30 seconds, while this one, it looks like it's hitting about 88 hours. Now, here's the part that will make the sysadmin pull his hair out, because this is the same file coming from the same server over the same network with vastly different results. Can you imagine trying to troubleshoot that? So this user over here is like, this download is taking absolutely forever. This person sitting right next to him, it works just fine. So it is throughput versus pissing off the sysadmin. Now, I want to ask you, like, how would you troubleshoot this? Nobody? you just change careers? What? So, like, I'll go ahead and tell you what you would do is, it's the standard troubleshooting tool, is you would eliminate hops. Just start eliminating hops till eventually this computer is plugged directly into here, and then it would start working, and then you would work your way back. So anyway, but that would be a long, arduous process of getting on the terminal and looking at the router and all that kind of stuff when the problem exists outside the router completely. So anyway, fun stuff. Now, to drive the point home of latency versus throughput, I like to do this. Raspberry video and show that ping is perfect, because that would probably be the first test that will be shown. So, excellent latency, terrible throughput. Now let's look at the reverse. Close that out. Now we got two big screens. I'll leave it here. So I don't need my web servers anymore. Instead, I'll launch VLC. For the latency test. Now, I'm going to, someone asked me earlier, I want to be clear, I think there was confusion, but Pakistander actually runs on Windows, Mac, and Linux, and Raspberry Pi. It runs on all that kind of stuff. I don't know if that, I mentioned something about being Windows only. That was the Pi Player app. But Pakistander runs on everything. And for things that it does not run on, you can obviously download the source code and compile it. So I just wanted to make that clear. For Raspberry Pi itself, it actually runs on Raspberry Pi, but you have to compile the source code. I did not build it for ARM processors. All right, so I've got two VLCs, and we're going to do a latency test by launching my own VLC. And here is what I'm going to send. Let me do open reset. So I'm going to send this clock video to both sides. It's just a clock that counts to 1 minute for 20 minutes. So open network stream, and no, not network stream. We want to stream this video, that guy. Now I'm showing you the steps because maybe you want to set up your own ad hoc streaming server. This is how you could do it. Stream that file, yes. And I know Dan from yesterday is a fan of RTSP, but I'm going to use RTP because I want to stay purely UDP. See, the RTSP you can do UDP, it does UDP also if you want, but there's like a TCP connection at first, and then it sends out UDP. This is going to be pure UDP. So I'm going to add that. I'm going to port 50,000 to 5004. This is going to be Raspberry video. It's the address. And I'm going to do another one. Raspberry video to the other port that I set up. Next. Next. If you want to do it all on the command line, you could do something like that. Hit stream. I must have did something wrong. Stream. Add this file. Stream. Next. RTP. Raspberry video. Next. RTP. Raspberry video 50,005. Next. Next. Stream. It is not picking up the video. Open. Here's 50,000. There's that one. Open. Open network stream. 50,004. There it goes. I don't know why. VLC has all kinds of quirks. Like if you let it sit there long enough, it just loses its brain for some reason. I don't know why. But anyway, we got it. Let's make it a little bigger. So you can see that these are in sync. They're playing the same video, which is what we want. Now, we're going to learn latency by making the sysadmin angry again. So watch what we do. I'm going to mess with the one on the left. So I got to make another classifier. I'm headed this direction. Before I was pulling from the Raspberry Pi. Now I'm pushing to the Raspberry Pi. So I have to go on the left. So enable the classifier. Add new filter. And I am sending it. Enable. I'm sending it to 5004 with UDP. Apply. And I'm going to do another flow 2. There it goes. So it dropped down here. It's showing me the traffic right here. And I'm going to add a delay of 5 seconds. There it goes. 5-second delay. So once again, we have same server, same destination, same server, sending the same data to the same hub. Two things running side by side with vastly different results. And if you're trying to troubleshoot this, you would have all kinds of issues. Like I said before, you would troubleshoot it the same way before is you would do all kinds of configs, tests, and it wouldn't work. And then eventually you start decreasing your hops till you actually get to right here in order to figure out what's going on. Now, if you had this playing at home, it'd be intolerable. Now, if you had just one screen, it'd probably be fine. Like you start up Netflix, there's a 5-second delay, then you get all your data, no big deal. But I want you to think about a video stream with a channel of audio and video. So it's very common when you're transcoding audio and video that you would separate audio and the video, send them on 2 different channels, then merge the 2 later into one stream. What would happen if one was audio, one was video? It'd be intolerable. Does anybody know what the tolerance actually is for audio and video difference? Like How much can the human perceive? Any guesses? 100 milliseconds? 10? It's actually around 20 to 50. Like, that's about all you can get. Then the human can perceive the difference. They wouldn't know whether it's leading or lagging, but they'll know that something is wrong. And I have it at 5 seconds. So if I was to do ping, it would work. But finally, what's the throughput of that video versus the other video? If I was to measure the throughput, what would I get between the two? They'd be the same, exactly. Even though one is completely unusable, you get the same throughput. So that's what I tell the students. Like, same throughput. That's why you need to know the latency. So the previous demonstration had a very good latency but terrible throughput using a download. This one has really good throughput but terrible latency. So that's why you need both when you measure your network performance. Are there any questions about this demonstration?
So if I hypothetically wanted to put this in between an NTP server and a alarm system that would keep the doors open or closed at a certain time, so you would make it where the clock would make it seem like it was not as when it was supposed to close. So I wanted to stay open till 7 p.m. when it was supposed to close at 6 p.m.
That
Would it affect the latency or thing? And would there be smaller costs that I could use? Hypothetically.
I actually don't know. That might work. This is a pretty high-end box, but okay. So what he asked was he wanted to know if he could mess with an NTP service.
No, not the NTP service itself.
But the response.
Getting it to the computer that is operating the door system that tells it on a timer that it's 7 p.m. or 6 p.m. shut the doors, but you're making the time slow.
I got it. Okay, so a command to shut the door, close the garage door at 7 p.m. You capture it with this thing and delay it for X number of time before it reaches the garage door. And that, yes, you can absolutely do that. This thing has a really deep buffer. Now, I'm guessing like that's probably just like a one-off command that might be at most a kilobyte. And you can see here, I have 5 seconds, really bad video, but video nonetheless, 5 seconds. You know, I've dragged this up to 30 seconds. So yeah, it could definitely hold a command for however long you need. No biggie. I mean, this thing's only about 8,000 euros. I mean, what's the big deal? I don't know. You'd have to search around. But yes, theoretically. It may be easier if you were to just capture it and you just build your own echo service. It's not hard to do. So you would have like a little Raspberry Pi that listens for it, capture it, and just kind of hold it in memory yourself to spit back out. Or you can buy one of these. Anyway, yes, absolutely yes. You can do that. It's a good question. Anybody other questions? Ask me more questions. Good question. So the reason why you hit the play button and it grinds for like 10 seconds, well, not 10 seconds, a while before it plays, or hit stop, it grinds, is because I'm doing a system call to Linux to launch a separate app to play it till it runs out. And the way the stop command works is I do a kill all system call to the name of that to kill it. So the thing is just playing, then it waits for like a pseudo kill to kill it off. It's extremely inefficient way to do it, but I don't care because I'm just trying to do a demonstration. That's why it's slow.
Anyone else? Any more questions? It's the last talk of the day, guys. The last chance to grill Dan. No? Looks like that's it. All right. Thank you so much, Dan.
Thank you so much.